Not Year 12, infinite series, or the infinite sum, limit of a geometric series. So let's see what they say about this in the textbook. Now, there are two types of series. There's divergent and convergent. So in some geometric series, you can see here, they diverge. Their sum is infinite. They're just getting bigger and bigger and bigger, huge. Whereas other series, they converge. And the most common one of these is to think, okay, the frog jumping up at the well or trying to reach the end of a room. So let's say a room was 8 meters long, 8 meters long. And you start here and you're walking to the end of the room. And this is one of Zeno's paradoxes. He said, righto, there's going to be a midpoint there. So you're going to walk halfway and you're going to reach that halfway point. So you're going to walk 4 meters. So you walk 4 meters and there you go. And then you're here. And then there's another midpoint halfway between this point and this point. And that's 4 meters, and half of that is 2. So you're going to walk another 2. And then you're here. And you're 2 meters away from the wall now because you've walked 6 meters. But you're going to get another midpoint between here and here. And that's 1. And then you're just going to keep getting more and more midpoints. You're going to get another midpoint between there and there, which is a half. Come on. And so on. So this series here that they're talking about over here, come on, where's my screen? And they're talking about here that converges is exactly that scenario. And it baffled a lot of people for a while because Zeno said you'd never reach the wall. But then Zeno didn't, and this is where mathematics comes in. We can do the sum of infinity, the sum to infinity. We say that this has a limit and the limit is 8, and that we can work out this sum by dealing with the limiting sum. All right, the sum to infinity. So if ever you read any of Zeno's paradoxes, that's what we're dealing with. We're talking about infinite series, infinite sums. So let's prove it. And Margaret does a pretty cool proof of this, so I'm just going to follow hers. The limiting sum of a geometric series, that means something that's going up. All right? The series is going up. It's getting more and more because you're adding, but because you're adding by a fraction. So the first thing to note is that a limiting sum converges when R is a fraction. Right? The absolute value of R is a fraction, less than 1. And you get this formula here, which is the sum of this series. They don't even have to say m because it's a sum of the infinite series. This infinite sum is a on 1 minus r. It's so easy. So how do they do it? Well, here's our formula for any series. And you notice that they've taken the second one, where r is a fraction between -1 and 1. Now, what you need to know is that any fraction r to the n, the limit as n approaches infinity. So imagine you've got a half there, which is that series we were talking about earlier, and you do a half to the power of 100, or even more, a half to the power of 1,000,000. It's going to get very, very, very close to 0. So we say the limit as a half goes towards infinity will be 0. And that's what they're saying there. This limit means that it's going to go towards 0, which means this bit becomes 0, which means all I'm left with is a times 1. Well, a times 1 is a, and hence you get this beautiful formula. A equals 1 minus r, a over 1 minus r. So this is not too difficult because there are only two variables, a and r. and then the limit. So let's have a go at some of these. The first thing you must establish is that that it has a limiting sum, and that's what they're asking you to do for the first one. So you've got to find R. So which series has a limiting sum? So if I look at 1A, let's go. If I look at 1A, I just have to get R as a fraction. Well, R equals 3 over 9 equals a third. Well, that's a limiting sum. B, a half, R equals a half over a quarter. Well, what do I do when I divide by a fraction? I multiply by the reciprocal. So a half times 4 over 1 equals, 2. Well, that doesn't have a limiting sum. All right? So all you have to do is do one term over the other. If you get a fraction, and I do them on your calculator. Now, I know that it said find the limiting sum for 1, but I'm going to do that in question 2. And these are quite easy. So we'll do a positive and a negative if there's a negative one there. Beautiful, there is. So I'll do A and G. So here's 2A. So A equals 40 and R equals 20 over 40, which is a half. So S of infinity, the limiting sum, is A, 40 over 1 minus a half. Well, 40, I don't need my calculator here. 1 minus a half is a half. What do I do when I divide by a fraction? I multiply by the reciprocal. The limiting sum is 80. Let's have a go at G. So 2G, I'm just going to write my stuff down before I move across. A equals negative 12 and R equals 2 over negative 12, which is negative a sixth. All right. So sum of infinity is A, negative 12 over 1 minus a sixth. I'm going to do this one on my calculator this time. So I've got negative fraction, and I've got negative 12 over 1 minus negative 1 on 6. Negative 72 on 7. I'm just checking that. Yep. Negative 72 on 7, which is negative 10 and 2/7, which is the answer. All right. So finding the limiting sum, relatively easy. Finding the difference, that's pretty easy. I'll let you have a go at that. Let's have a go at one of these ones where they ask us to find something else, to find the first term. So 4, S of infinity is 6, and A we don't know, and R is a third. Well, it's just an equation. You just have to put it in solvent. 6 equals A on 1 minus R, so 1 minus a third. 6 equals A on 2/3. Now, there are two ways to think about this at this point. I'm going to show you the way that I would do it. I'm just going to multiply that 2/3 across. So I'm going to get 6 times 2/3 equals A. And that's going to be 4. I'm just got to check this, question 4. The other way is to go 6 equals, I'll just rewrite that as I'm going to go A multiplied by the reciprocal 3 on 2, which means I'm going to go multiply that 2 across and divide by that 3. Oh, okay. Either way, doesn't matter. Now, let's create some space and have a look at a couple more questions. This is particularly easy, this one, limiting sums. Hopefully they got a decimal in there somewhere about showing that 0.3 repeater is a third. Find the limiting sum of a series is that. Yep, the second term of a series is that, and the second term and the limiting sum is that. Find the value. Let's have a go at that. Question 10. So, A and R we don't know, but we know that the second term, T of 2, equals 2. Well, that's A, R to the 2 minus 1 equals 2. So AR equals 2. All right. Also, we know S of infinity equals 9. So 9 equals A on 1 minus R. Well, I can either rewrite this equation. So R is a subject or A is a subject. And I'm thinking it's going to be easier for me to write A as a subject and then substitute it into this one. So let's try that. A equals 2 on R. I'm going to call this equation number 1. I'm going to call this equation number 2. And I'm going to sub 1 into 2. Okay, so 9. Now wherever there's an A, I'm going to write 2 on R. 2 on R over 1 minus R. Well, what I'm going to do is I'm going to multiply all this over there. Okay, so 9, 1 minus R equals 2 on R, which gives me 9 minus 9R equals 2 on R. Let's multiply that R across. 9R minus 9R squared equals 2. Well, I'm going to get a quadratic. Let's take everything over the other side. 0 equals 9R squared minus 9R plus 2. Well, let's try a common ratio. 9 times 2 is 18. So what multiplies out to 18 adds up to 9? I reckon minus 3 and minus 6. So 0 equals 9R squared minus 6R minus 3R plus 2, which gives me, we'll take 3R out of this, 3R R minus 2, and we'll take if I take 3 out of that, I'm going to get 3R minus 2. And if I take negative 1, if I take negative 1 out of the second one, I get 3R minus 2. So I've got 3R minus 2, and I get 3R minus 1. So R equals, therefore, R equals 2/3, or R equals 1/3. Well, so I've got two options here. Let's go back here. If R equals 2/3, if R equals 2/3, A equals 2 over 2/3, how do I divide by a fraction? I multiply by the reciprocal. So 2 times 3 on 2, the 2's cancel, A equals 3. If R equals 1/3, A equals 2 over 1 over 3. 2 times 3 over 1 is 6. So I have two possibilities. I have A equals 3, R equals 2/3, or A equals 6, R equals 1/3. Two possible answers. Right? And solving simultaneous equations. I'm going to let you have a go at that. And if you're having any other problems, email me. I'm sure you will as you get on to questions 11 to 17. And once we've done that, you're finished. That's this exercise done. So good luck.